5.4, number 69. So here's the identity that we have to prove. Definitely left-hand side is more complicated than the right-hand side. That's where I'm inclined to start. Plus I've got these difference formulas that I can use for sine and cosine. Another thing that jumps out to me when I look at this is that when I look at the right-hand side, now I've got sine t, cosine t in the denominator there, which is the common denominator if I were to add these two fractions up, right? Which kind of leads me to believe that's somewhere on the horizon, right? Somewhere in my future is probably going to be to find a common denominator and add these two expressions together. But before I jump the gun and do that, right, let's just use the difference identities here to rewrite those. So I'm going to start on this side. We've got, I'm just going to go ahead and rewrite these using the difference identities. So this is going to be sine s cosine t minus cosine s sine t. Right? Did I get the right sine s sine cosine t minus cosine s sine t? Good. Over sine t. Here I'm going to get cosine s cosine t, and then the sign changes, plus sine s sine t over cosine t. At this point, I mean, I don't think I have anything that I can do here, right? None of these things are like terms. I can't factor anything out and hope to cancel anything in the denominator. So now's when I think I'm going to go ahead and do this thing, right? Find common denominators so I can add these things up. And hopefully by that point, I'll have some things in common that I can kind of cancel and stuff. Well, let's see. So if I multiply by cosine t here, and sine t here, now let's see what I get. So I've got sine s cosine squared t, right? When I distribute to that term. When I distribute to this term, I've got nothing nice. Cosine s cosine t sine t. Okay. For this term over here, I'm going to have cosine s sine t cosine t plus sine s sine squared t Does that give me anything nice? Let's see. Got sine s cosine squared t. Sine s sine squared t. Well, okay, so not quite matching, although I could use a Pythagorean identity, right? Like I could combine these, factor out the sine s, and then cosine squared plus sine squared is 1. So that whole thing is just going to, that's where I'm going to get the sine s from, I bet. Okay, because then this thing, cosine s, cosine t, sine t. So these two are the same, and they cancel. Those two cancel. Oh, there it is. There it is. Okay. So, so at this point, we've got sine s, cosine squared t, plus sine s sine squared t over cosine t sine t. Okay, I can factor out a sine s from the numerator. Okay, and then cosine squared t plus sine squared t is just 1, right? This thing is just 1. So, and sine s times 1 is, of course, just sine s. So there we have it, right? Sine s over cosine t sine t. Okay, there's that one.